2011 Grade 11 Hypatia Math Contest. Piravina must make a trip from A to B, from B to C, and then C to A. Each of these three trips are made either by a bus or by an airplane. Cities are at a right angle, and C is 3,000 from A, and B is 3250 from A. To take a bus, it costs 15 cents per kilometer, and to take the airplane, there's initially a flat fee of $100, and then 10 cents per kilometer. To begin her trip, she went from A to B to determine the cost. All right. So the first thing, of course, is we just have to figure out the formula, and it's a fairly straightforward formula, which would be the distance, which in this case is 3250 kilometers, times the rate, which is 0.1, and then don't forget that $100 booking fee. So add that. So this is 325 plus $100. So that would be $425. Determine the distance she travels. Okay, so the whole trip, two of the distances they've already given us, so I guess we have to figure out the other distance, which is BC, and then we can use that Pythagorean relationship to figure out that distance. So it would be BC squared plus 3,000 squared is equal to 3250 squared. And when you do this math, fairly straightforward, it is 1250. And of course, it's kilometers. Part C. Piravina chose the least expensive way to travel between the cities, and her total cost was 1012.50. Given that she flew from A to B, determine her method of transportation from B to C and then C to A. Okay, so I guess we got to do a little bit of math here in terms of choices, B, C, and then C to A. Okay, so the first one, they told us that she's going, she flew, so that one's an airplane. And that can be easily figured out. It's $100 for the booking fee plus the $12.50 from A to B, right? A to B is, sorry, not $12.50. A to B, well, that's just what we did up here. Ah, okay, I'm getting confused. I was wondering, that sounds very familiar. So that's 3250 times 0.1. So we already did that. And that worked out to be 425. So this is 425. Okay, so this is a fixed. And then they're saying, what are the other ones? So I guess we'll have to do it for airplane and bus for these two guys. This one and this one. Okay, I got it. Okay, well, they told me that this trip is going to cost a total of 1012.50. Now, 425 is already accounted for, so let's see how much more I need to account for here. I got to subtract from this the 425, and when I do, what I have remaining is $587. Yeah, and 50 cents. Okay, so I've got to account for this for the remaining two trips. So let's figure this out. Airplane from B to C would be the $100 booking fee plus the $12.50 times the 0.1, and that is $225. A bus for B to C would be same distance, but this time is just $12.50 times 0.15, and that is $187.50. Okay, same kind of story for C to A. $100 for the booking fee plus 3,000 times 0.1, and that's $400. And then finally, this guy is 3,000 times 0.15, and that's $450. So when I stared at this, it looks like if I use this and this, those two together will total $587.50. So I'm going to have to go by bus from B to C and by airplane for C to A. A function is such that f at x minus f at x minus 1 is 4x minus 9 and f at x is 18. Determine the value of f at 6. Okay, so I guess I would just plug it in. F at 6 minus f at 6 minus 1 is equal to 4 times 6 minus 9. So all I've done is just use that formula. F at 6 is what I'm trying to figure out. This becomes f at 5, and this becomes 24 minus 9, which is 15. So therefore f at 6 minus f at 5 they gave me, so that's very helpful. And therefore f at 6 to me looks to me like 33, if I have not made any mistakes. B, determine the value of f at 3. Okay, so f at 3, how will I do this now? F at 3, I think I'll have to do a double one. Yeah, meaning I'd have to first figure out f at 4. Yeah, and then figure out f at 3. Okay, so again, using the same formula, f at 4. So I'm going to use f at 5 because that's the only one I know that's close to f at 4. And then this would be f at 5 minus 1. And this would be 4 times 5 minus 9. So this would be f at 5 minus f at 4 is equal to 11. And f at 5 is 18. So that I know. That is 18. So 18 minus 11 is f at 4. And therefore f at 4 is 7. Okay, that's what I thought. So then I have to do the same thing again, but this time using x equal to 4. So that would give me f at 3. So f at 4 minus f at 4 minus 1 is equal to 4 times 4 minus 9, right? So f at 4 is 7, and this would be f at 3. And this is 16 minus 9, which is 7. So it looks to me like f at 3 is 0. Okay. Part C. If f at x is equal to 2x squared plus px plus q, determine the values of p and q. So f at x this time is equal to 2x squared plus px plus q, and they want me to figure out what are the numerical values of p and q. Okay, let's try to figure this out. So the first thing, of course, is what is f at x? That definition was 4x. Well, let me just write it up here just to remind you guys. For f at x minus 1 was equal to 4x minus 9. So if I just isolate for f at x, it would be 4x minus 9 plus f at x minus 1. Yeah. And this part is just your 2x squared plus px plus q. Px plus q. Okay, so that's how you would start. Now at this time, let's see here. I'm trying to think what's the best way of doing this? Or something that might be just very straightforward is just plugging it back into here. So if I take that and I have f at x minus f at x minus 1 is equal to 4x minus 9, just using that and then using this. So that would be 2x squared plus px plus q minus f at x minus 1. So x minus 1 instead of the x. I think that this probably would be the way to go. And then this is 4x. Wait, hold on. Yeah, it's 4x minus 9. Yeah. And then, of course, I got to do the big long song and dance here of having to expand this and collect like terms and all that stuff. Okay, so let's do that. 2x squared plus px plus q minus, oh boy, what is this? 2x squared minus 4x plus 2 plus px minus p plus q. And that's 4x minus 9. Okay, I think that this should work. So let's do this now. 2x squared plus px plus q minus 2x squared plus 4x minus 2 minus px plus p minus q is 4x minus 9. So a lot of stuff here cancels, so that's good. That cancels with that. This cancels with this. This cancels with that. So all I'm left with, it looks like, is 4x minus 2 plus p is equal to 4x minus 9. The 4x's cancel from both sides, so I'm just left with minus 2 plus p is minus 9, and therefore p is equal to minus 7. All right, so that worked. But I still got to get q. Okay, so how do I get q? I guess I just go right back to the same formula. I don't think of it. I can't think of anything else. So f at x, that one. We are given f at 5 in the question, right? I think it was 18. Yeah, it was 18. So let me just use x equals 5. So that means f at 5 minus f at 5 minus 1 is equal to 4 times 5 minus 9. Oh, wait. Hold on. That doesn't help me. Because that's useless. Or is it? I wonder. Yeah, that's going in a different direction. I think we'll just use this formula that they gave us in the question, that f at x is equal to 2x squared plus px plus q. I think that'll be good enough. And we can use the fact that in the question they gave us f at 5 is 18. And then we just figured out that p is minus 7. I think that should be sufficient. All right. No problem. A little bit of trial and error here. And that's what math is all about, I guess. So f at 5, that would mean this will be f at 5. And then if x is 5, that would be 2 times 5 squared, plus that's p times x plus q. All right, so f at 5 is 18. This is 50. P is negative 7. So negative 7 times 5 is minus 35. And that's q. So that's going to be 18 minus 15. So q is equal to 3. There we go. Q is 3. P is minus 7. In the diagram, square ABCD has side length 4. Triangle AB is equilateral. Line segments B and AC intersect at P. Point Q is on BC so that PQ is perpendicular to BC and PQ is equal to X. Determine the measures of triangle BPC. All right. Well, BPC. Okay, so let me use a different color here. All right, so first let's think about this for a second. The line from A to C basically cuts that square in half. Now, it's a square, so obviously these are right angles. So if it cuts it in half, that means this angle will be 45. Yeah. Okay. Where do I go from here? Okay, this is a equilateral triangle, right? ABE. So that means that these angles are 60. That's 60 and so on. So that means this angle would be a 30. Yeah. Okay, so that's pretty good. And then I guess the third angle of, triangle BPC, this guy, would just be 180 minus 30 and minus 50. So that's 105, I believe. So that's going to be 105. So the angles are going to be 105, 45, and 30. And of course, you just explain it in words, like I did verbally. Just write it out as to how did you get 45 and how did you get 90 and so on. Find an expression for the length of BQ in terms of x. BQ in terms of x. Okay, so this triangle, BQ and P, they told me that that's a right angle, right? And this angle in here is 30. So that means this angle is 60. So that's a 30, 60, 90 triangle. And all 30, 60, 90 triangles have a certain ratio for the sides. And that ratio is 1, 2, and root 3. So this is x, right? PQ. So that means that BQ over PQ is root 3 over 1 in terms of the ratio. So BQ over x is root 3 over 1. So therefore BQ is root 3x. And I think that's what they're getting at, so let's just put that in. Root 3x. B to Q. Determine the exact value of x. Okay, exact value of x. All right. Let's see where I have to go here. Well, the length of the square is 4, right? So from B to C is 4, A to B is 4, like that kind of scenario. So B to C is 4. And then B to Q, I have root 3x. Okay, I got it. If this is a right angle, then this is also a right angle. And since this is 45, this angle is 45. So that means that that's an isosceles triangle, that one, that PQC, triangle PQC. Since two angles are 45, that basically means that it's isosceles. So that means that PQ is the equivalent to QC. So Q to C is X. Okay, so that means that since BC is equal to BQ plus QC, and BC is 4, BQ is root 3 over X, and QC is X. There you go. We can now solve for X. All right, so let's solve for X. So 4 is equal to X times root 3 plus 1, and therefore X is equal to 4 over root 3 plus 1. And that is your answer. But they usually want you to rationalize the denominator. So we can do that. Multiply top and bottom by the conjugate. So we get 4 root 3 minus 4 over root, let's see here, 3 minus 1. So that's going to be 2 root 3 minus 2 is equal to X. Yes, hopefully that is correct. All right. And then finally, what's the last one? Determine the exact area of APE. APE. So APE is which guy here? This one, right? APE. All right, so how do I do that? I think we're going to have to do a multi-step process here. Let me think about this for a second. Okay, I think I got it. So there's several ways of doing this, but I'll just do it what I think is the simplest way. So the first thing is, if you notice that square is cut in half, right? So that's what? ABC, that one. So that area I'll figure out, and that's pretty straightforward. It's just the square, which is 4 times 4, divided by 2. So that's 8. And then what I need to do is figure out the areas of some of the smaller triangles. So I got to figure out the area of this guy here. I'll label it BPQ. That one. And I think I have the dimensions. So it should be pretty easy. 1/2 base times height. The base is PQ, so that's X. And X I had figured out already, right? Yeah. X was 2 root 3 minus 2. It's over here. Yeah, this guy. And then the height is, for this guy, it's going to be BQ. That's root 3x. So root 3x is what? 6 minus 2 root 3. You just take x and multiply by root 3. So this looks to me like root 3 minus 1 times 6 minus 2 root 3. And that is going to be 8 root 3 minus 12. So I just expanded and collect like terms. I can do that pretty quickly. Okay, so that's good. Now I'm going to do the very similar, but this time in this different triangle. This one is PQC. So again, the area is 1/2 base times height. We can use this as the base, which is x, PQ. So that's 2 root 3 minus 2. And we can use this as the height, which is QC, which is also x, 2 root 3 minus 2. So when you expand and collect like terms, you get 8 minus 4 root 3. Now, I'm going to concentrate on this sort of weird shape, which is ABP. ABP is basically the equivalent of ABP is equivalent to ABC minus BPQ minus PQC, right? So ABC, I got 8 minus this 8 root 3 minus 12 minus this 8 minus 4 root 3. And when you collect like terms there, you get 12 minus 4 root 3. Okay, so now we are in the final step. And the final step is basically trying to figure out, what is that again? APE, right? Yeah, APE. So APE is the equilateral triangle, which is ABE, minus the APB. Yeah. Well, the ABE, that is an equilateral triangle, so I can easily figure that out. that is, wait, hold on. I think I drew it upside down. There we go. That's better. That's A, B, E. And it was 4, 4, 4. And if I draw that, that's going to be 2. And this is going to be 2 root 3. Because the ratio of the sides are 2, 1, root 3. So the area here of ABE would be 1/2 base times height, which is 4 times 2 root 3. And then APB, we just got 12 minus 4 root 3. So therefore, this looks like 4 root 3 minus 12 plus 4 root 3. So that is 8 root 3 minus 12. And there you go. Determine all real values of x satisfying the equation x to the power of 4 minus 6x squared plus 8 is equal to 0. Well, the first thing I would do is make a little substitution, and that substitution is x squared equal to something. I'll just call it a for now, and that way we can proceed without too much difficulty. All right, so once I make that substitution, I get a squared minus 6a plus 8 is equal to 0. Now this factors pretty nicely. It's a 2, 4 minus minus. Yep. So therefore a is equal to 2 or a is equal to 4. That means x squared is equal to 2 or x squared is equal to 4. So therefore x is equal to either plus or minus root 2 or x is equal to plus or minus 2. And those are the solutions. Determine the smallest positive integer n for which x to the power of 4 plus 210 x squared plus n can be factored as such. And these are integers and r cannot be 0. All right. Okay, so I guess I have to expand this. So x to the power of 4 plus 2010 x squared plus n. And they're saying that can be factors as x squared plus rx plus s multiplied by x squared plus tx plus u. And of course, we got all these parameters, or conditions, I should say. Okay, so let's expand this. X to the power of 4 plus tx cubed plus ux squared plus rx cubed plus rtx squared plus rux plus sx squared plus stx plus su. Okay, so I think at this point we have to collect like terms and compare coefficients. I think that's the strategy here. So once we compare coefficients, everything should fall into place. So x to the 4th, and then we're going to have a coefficient for x cubed, and that's, I believe, t plus r. Yeah, and then we're going to have a coefficient for x squared, which looks like u plus rt plus s. And then for x, that coefficient is ru plus st. And then finally, we get this little su. Okay, so now let's compare coefficients. So there is no x to the power of 3 on that side. So that basically means that t plus r is equal to 0. Yeah. T plus r is equal to 0. There is an x squared coefficient, so that means that u plus rt plus s is equal to the 2010. No, there's no x, so coefficient, so ru plus st is equal to 0. And finally, this su will equal to n. Okay, so let's see what we can get from this, what kind of math I can crunch out of here. From this guy up here, t is equal to negative r. If I put that in here, if t equals negative r, then that means that we're going to have ru minus rs is equal to 0, and therefore u is equal to s. And from this guy, that means u squared is equal to n since u is equal to s. Okay, that's about as far as I can go from that. Now, our question is telling us that we need to minimize n, right? They're asking for the smallest possible n. So if I want the smallest possible n, and n is equal to u squared, basically what I'm doing is minimizing u squared, or minimizing u. So I guess that's what I'm going to concentrate on, trying to get the smallest possible value of u. Okay. So let me use this, since the only one I actually have a number for. Everything else is just letters. And let's see what I can get. So u plus rt plus s is equal to 2010, right? Yeah. So that means that u plus r, and t is negative r, so negative r plus u, since s is equal to u, is 2010. And therefore this is 2u minus r squared is equal to 2010. Okay. I think that's helpful. So if I isolate for u, I get 2010 plus r squared over 2 is equal to u. And if I write this a little bit different, it'll be 1/2 r squared plus 1005, I believe, right? Yeah. So basically, if this is a graph, and this was a plot of the graph where you have u and r, so this is, say, r, and this is u, I believe it would be a parabola like this. Yeah. So I think it'd be fairly straightforward to figure out the minimum value of u. However, we have some conditions, though, because r cannot be 0 according to the question. And then also u and r both must be integers. So those conditions have to be taken into consideration before we conclude what the minimum value for u is. So let's try, since r can't be 0 and r has to be an integer, let's try r equals 1. Because I want the minimum value for u, and that's going to happen with the minimum value for r. So if r equals 1, I get u equal to 1005 plus 1/2. So that's not an integer, so I got to keep going. If r equals 2, I get u equal to 1005 plus 2, and that's 1007. So that's the minimum value. So since n is equal to u squared, that would be 1007 squared, which is 1014049. So that is the minimum value. And finally, we get to part C, which says that if x to the power of 4 plus mx squared plus n cannot be factored, as in part B, for any integers m and n, with n minus m equal to 37. So they're basically saying that x to the power of 4 plus mx squared plus n cannot be factored the way it was in part B, which is this whole big long x squared and all that stuff. And I'm assuming the same kind of conditions. Yeah, most likely. And then they throw in another condition that n minus m this time is 37. So I think it's the same process, just like we did before. You expand this all out and you compare coefficients. So I'll let you guys do that. But when you compare coefficients, just like before, we have t plus r is equal to 0. Remember the comparing coefficients right here? Where was it? I did it somewhere. Oh, here it is, right here. So that's basically all I'm doing. But this time, I'm doing it for this guy. U plus RT plus S is M this time. RU plus ST is 0. And then SU is equal to N. So, same kind of story. The only difference is I've got an M in there this time. And I think last time it was 2010. Okay. So, let's then use our new condition of n minus m. This is 37. So n minus m. So n is SU according to this, and m is all these guys. So that's minus u minus RT minus S, and that's 37. And then I guess just as before, this led to t equals minus r, and this led to u being equal to s once we made that substitution, if you remember. So let's substitute those guys into here, and when you do, you get u squared minus u minus r squared. If I'm done this correctly, I think this would be a plus. This should be in brackets here. All this. Yeah. So that's going to be minus r. So then if you take it out of the black brackets, it'll be plus. And then the s is a u. And then there's this u, so it'll be minus 2u. Minus u again. Yeah, okay. So collecting like terms, it looks like it's u squared minus 2u plus r squared is 37. Okay. So now I'm going to just use a little bit of fancy algebra. Nothing extremely tricky, but I'm just going to add a plus 1 so I can factor it. And that's it. And then that's an r squared. And then if I added plus 1 to that side, I have to add plus 1 to this side, like that. And the only reason I'm doing that is just to make it factorable. And if it factors, then it could be, this guy can look a little bit easier to work with. So that's going to be u minus 1 squared plus r squared is equal to 38. And then now I'm going to isolate for r. So it's going to be 38 minus u minus 1 squared square root, plus or minus, of course. So we could put plus or minus, and that's going to be r. Okay. So now we want to figure out integer solutions for u and r, correct? So let's see if we can get integer solutions for u and r. And you make a little table here. And this table, basically, you're using our parameters that u and r are both integers. So you start with integer values for u, like 1, 2, 3, 4, and so on, or -1, -2, and then see what the value is for r. And as you can see from this table, there is no integer value or solution for r. Now you say, well, what about other values of u? Like if you say, you know, I've only gone from u minus 5 all the way till 7. Now, what if I put in like 8 or u equals 20 or whatever? If you do other values, for other values of u, what happens is what's underneath the radical becomes negative. So 38 minus u minus 1 squared, that becomes less than 0. And therefore r would therefore be, there would be no real solutions. You'd have like a negative under the root sign. So there'd be no real solutions for r. So basically, it's not possible to have both u and r integers if you're trying to factor the x to the power of 4 plus m x squared plus n as you did in part B, with the condition that n minus m is equal to 37. So basically, if you try to factor this as you did in part B with this condition, it's not possible to have u and r as integers. So the conditions cannot be met. And since we've shown that the conditions cannot be met, we have proven that there is no way for this to be done.